Welcome to lesson 3.1 in algebra. We're going to be looking at graphing linear functions in this lesson, and we have several different parts. Primarily, we're working with functions, but we'll look at a couple of linear equations that include a particular linear relation that's not a function necessarily. But generally speaking, linear equations, they're based on this idea, this key term, linear. Linear equations form a straight line when graphed. Linear equations form a straight line when graphed. So an example of what a linear equation might look like might be a linear equation like this. This would be a linear equation. I could have a linear equation that looks like this. I might have a linear equation that looks like this, and it's kind of a horizontal line. And I could have a linear equation that is a vertical line. Here are some counterexamples. These are things that are not linear equations. Something that's just a plotted point. That is not forming a line. Something that's curved, like a quadratic, is not a linear equation. We also have a special type of function that is made up of two linear equations, but these are two separate straight lines, not a single straight line, so that is not a linear equation. And we might also have all kinds of things. We, in pre-calculus, might deal with functions that form circles or other shapes like that. So these are all not linear equations. They are not a single straight line when graphed. We'll also find that linear equations are going to have one or two variables. So one or two variables, which we usually represent with x and y, and these are going to be variables to the power of 1. So nothing will be squared. We're not going to have a squared variable. We're not going to have a square-rooted variable. So what these might look like in their equation form might be something like 3x plus 2 equals 5. Could be a linear equation. I have one variable, and that's it. I could have y equals 2. That has one variable. I could have, and this is what we typically refer to as a linear equation, maybe 3x plus y equals 3. So I have x and y, that's two variables. That's okay. Or I might write this in the form y equals 3x plus 1. So I have one variable, a second variable, and that's it. All right. What are some things that would fail this test? Well, if I had no variables, like 5 equals 2, no variables is not a linear equation. If I had more than two variables, x plus y plus z equals 5 is not a linear equation because, not for our purposes right now, because it has more than two variables. X squared equals 5 is not linear because a variable is being squared, or y equals the square root of x. That is not x to the first power, so that is not a linear equation. And then we can have no more than one variable per term. No more than one variable per term. So, for instance, each of these are all examples. We have 3x plus 2, that's fine, equals 7. Here's a term, one variable. Here's a term, no variables, that's okay. We want no more than, so 0 variables is fine, and zero variables. X plus y equals 3. One variable in the term, one variable in the term, no variables in the term. Those are all okay. We have a problem if we do something like x, y equals 7. This is not linear because this one term has two different variables. So this is not a linear equation. Or x over y plus 3 equals 5. This term right here has the variable x and the variable y, so it is not a linear equation. Okay, so we should be able to identify what is a linear equation versus what is not a linear equation. Linear equations, another property of them is that they're written in the form ax, in other words, some coefficient, this is going to be a coefficient, x plus some other coefficient y equals c, which is a constant. That is a number with no variable, which we've defined before. All right, and has several key properties, key characteristics that come from this form. A and B, these coefficients, are not both 0. So we can't, in other words, we have to have a variable. We can't have no variable at all. So that could be just 3x equals 5. In other words, this is a y coefficient. I have 0 y's here. Or I could have 2y equals 3 and 0 x's. So this, we have a little hidden 0x added here. Or I could have negative, let's back here. I could have 2x plus y equals 4. So that would be fine also. Some things that would cause this to fail is if I don't have any variables. If it's 0x plus 0y equals 7, well, that's just 0 equals 7. It doesn't have any variables. It is not a linear, it's not standard form. Any other just plain numerical statement, even something that's true, 2 equals 2 is still not standard form. So A and B, the coefficients have to not be 0. Okay. Then we also have in standard form, you'll notice up here that ax and by are to the left of the equal sign and c is to the right of the equal sign. And we're going to look at several different forms of linear equations. This is just the one called standard form. It's just a definition. So ax and by are on the left. In other words, 3x plus 4y equals, and c, the constant, is on the right, so equals 7. Something that is not currently in standard form might be y equals 3x plus 7. So this is not in standard form because my 3x is on the right when it needs to be on the left. 3x plus 7 plus y equals 0. Well, now my constant is on the left. My constant should only be on the right. So we want our variable terms on the left, our constant on the right, and in standard form we didn't list it specifically, but we always write the x first and the y second. So it goes x, y equals constant. Okay. A third characteristic is that a, this first term, should be greater than or equal to 0. Okay, or in other words, a should not be negative. We want our x term to be positive, or if there is no x, then it's 0. Okay, so it could be positive or just not be there at all. So another example might be, for instance, 2x minus 3y equals 5, or x plus 4y equals negative 10. These are all fine. A counterexample, something that fails this test, might be negative 4x plus 3y equals 2. My negative here on B That's okay. My negative here as the constant, that's okay. But I have a problem if my coefficient of x is negative. That means it is not in standard form, and we're going to have to change that using our properties of equality in order to put this in standard form. Even negative x plus y equals 5. This is not in standard form because my coefficient of x is negative. Oh, one more example would be, we'll do two more examples, just kind of squeeze these in here. 2x equals 5 is a standard form where x is positive, and negative y equals 4 is linear and in standard form because the coefficient of x is an understood 0, and 0 is not negative. My coefficient of x can be positive, greater than 0, or equal to 0. So both of those are also linear functions in standard form. We have two final properties, and I kind of split these up, but they're very similar. The first is that a, b, and c should all be integers. All right, so we want coefficients to be in standard form. We want coefficients that are all positive or negative whole numbers. And in the case of a, we want just positive whole numbers. So again, as we could do 3x plus 5y equals 12. No radicals. Let's see here. We can do 7x minus 12y equals 8. These are all standard form. It would fail this if, for instance, we had a fractional x. Let's go 1/2 x plus y equals 7, or a decimal, maybe x plus 0.5y equals 7, or a radical, even something like, typically a standard form, we want to all have integers if we can. So x plus y equals radical 5 is not in standard form. And in fact, this can't be written in standard form. But this is not in standard form because a, b, and c are not all integers. We need all three of them to be integers. And then finally, we want them all to have a greatest common factor, of 1. In other words, we want them to be reduced. So if you were to think of these as different terms in a fraction, we don't want to have any common factors other than 1. So everything we've done so far still fits. 2x plus 3y equals 12. This is actually okay, although 12 shares a factor with 3, and which is 3, and 12 shares a factor with 2, which is 2. There's no one number that is a common factor of all three. I can't divide everything by a number and still have integers other than dividing by 1. But if I had, for instance, 2x plus 6y equals 12, this is not in standard form because I could divide both sides by 2 and get x plus 3y equals 6. That would be in standard form. This is not in standard form because I have some common factor between all three numbers together such that the equation could be reduced. Okay, so with that, how do we write an equation in standard form? This is our last piece for the first half of this lesson. We're going to start with the original equation, and each of these steps, 1, 2, 3, 4, 5, are going to match up with one of these characteristics, 1, 2, 3, 4, 5. Okay. The first step is write your initial original equation and make sure there is at least one variable term. If this first example has 2 variable terms, that's okay. This example has one variable term because no, that's it, has one variable term. That's also okay. So we have our original equations. Then we're going to use the additive or subtract, the add or subtraction property, you can abbreviate that, in order to get our ax and by on the left and to get our c, our constant, on the right. So that was that second characteristic, is ax and by are on the left, c are on the right. So in this case, I see that my y is on the left, that's good, but my negative 3x is on the right, and that is bad. So I'm going to use my additive property to add 3x to each side. I can't combine the 3x plus the y together. They're different terms, and the whole point is we want them to stay different terms. This means for this example, I now have 3x plus y equals 4. And I want to list my x term first. Okay. Example 2, my y is already on the left. You know, I'm going to change this example. Go ahead and add a negative there. And we're going to make this x. So quick little change. I'll make sure that that's on your printed sheet. Negative 1/3 x equals negative 1. All right. So my x term's on the left already. That's good. Negative 1/3 x. My constant is on the right. Okay. So my x term and y term's on the left. My constant's on the right. My x term and right term, y term, if any, are on the left. My constant's on the right. Okay. Then I'm going to use the negative 1 property, if needed, to make my x term positive. Now in this case, my x term, my a, is already positive, so I don't need to do anything new there. But in this case, my x term is negative. A is negative 1/3. So I'm going to use that negative 1 property, multiplying both sides by negative 1, so that now negative 1 times negative 1/3 is 1/3 x. Negative 1 times negative 1 equals 1. So now my x is positive. That's what's important there. All right. Then we will multiply by the greatest common denominator. We're going to multiply by the greatest common denominator to eliminate fractions. So if we have any fractions, we would multiply times that denominator. We don't have fractions here, so we don't need to do anything in this step, but we do have a fraction here. So our greatest common denominator is 3. We're going to multiply both sides by 3. And 3 times 1/3 is x. 1 times 3 is 3. And I'm just going to carry this down. No fractions. Okay. And then the final step, if necessary, it doesn't come up very often, but we would divide by the greatest common factor so that we are fully reduced. Okay. Now, 3, 1, and 4 do not share a common factor, so this is in standard form. And we're done. 1 and 3 do not share a common factor, so that's done. This last step comes up very rarely, but we want to have it in our notes just to be on the safe side. These are now in standard form. We could check these by the characteristics. We have 1 or 2 variables. The x and y terms are on the left with x first if it's there. The constant is on the right. Our x term is positive. Our a, b, and c are all integers, so they're positive or negative whole numbers or 0, and there are no common factors between those numbers. So we are in standard form, and these are done. All right, so that is the first part of lesson 3.1. We looked at the characteristics of linear equations. How do we know that we have a linear equation? And then specifically, what does a linear equation written in standard form look like? And then based on those characteristics of standard form, how can we rewrite an equation into standard form. Go ahead and make sure you have these all complete, and I will see you in class. Have a good day. Bye.